Hello everyone, this is Cameron Smith from TechLogix here today to go through the fiber optic workshop. This is what we call our Fiber 101 class. We've been doing this now for 4 or 5 years with CD at the CD events and actually several of the other trade shows and tech events literally worldwide now. And what you'll find is we kind of roll through the content here. This is a great introduction to fiber. This is where most people get started. There's a lot of different workshops and classes that we offer here at TechLogix. This is the first one that most people take. And then from here, you'll get into a little bit more hands-on with termination. Usually when we do this live, it is followed by a hands-on termination workshop. But we also have classes for how to sell fiber, which is actually a pretty popular class because obviously as we're talking about the things today, how optics tie into the AV installation, we got to be able to communicate that to our customers. Troubleshooting, design, all of these things play into that fiber optic system. But this is a good introduction to why we're talking about fiber, how we're talking about fiber, and it really should put you on pace to be able to design, troubleshoot, and then move into the next steps of installation. So let's start the conversation today with why fiber? Why is this becoming a really hot topic in the industry? And, I will take a little sidebar conversation. I'll mention that this is an overview presentation. We're not going to do a shameless pitch on TechLogix. So, before we spend our time rolling through the session, let me just say, if you need more information, the TechLogix website is a great place to go. Lots of this information's there. Lots of the product stuff's there. So media over fiber optics. Media, I like this phrase because fiber is really one of those all-inclusive platforms. Frankly, and I tell everybody, everything that twisted pair can do, fiber can do better with one exception, and that is transmit power. We're not sending power over these optical cables, over the optical electronics and all the different accessories and installation products that come in between. We don't deal with power. That means we have to think about that as we design the system. We'll talk through that here in a minute. But when it comes to bandwidth, especially future-proofing for things like 8K, and 12K and 16K, these specifications that have been launched now, and you're going to start seeing this year in the DisplayPort world, fiber handles all of that. Distance. Fiber goes long distances. We'll look at all these reasons why fiber is important. And it's really starting to replace the copper-based cables that we've used for years. But none of this really matters if we can't handle it, if it's not affordable. And those are some of the advancements that really came out of these fiber development, the technology that we're seeing on the market today. Now, for folks who are completely new to this technology, here's the good news. The fiber optic ecosystem, the different parts and pieces that we use, it's really not that much different than the copper ecosystem. So what do I mean by that? Well, we deal with bulk cable. And there's really two different types of technology in the audiovisual industry that you'll see. Polymer coated fiber optic cables, like those coming from Clearline, and also traditional fiber optic cables, like those coming from Corning. So two of the technologies that we really get hands-on with here at TechLogix, the Clearline SSF, these are the polymer-coated technology. You can buy cables with the polymer-coated fibers. We'll talk about why that's a really important thing here in a minute. But we also work with traditional Corning cables, ClearCurve, SMF28 Ultra. The same tools are used for both. The same connectors are used for both. The way to terminate is slightly different. When it comes down to the durability in the cables and pull ratings, they're very, very quite similar. But bulk cable is part of most of these installations. Specialty cable, things like direct burials, armored, tactical, bundled cables, right, where we're taking a couple of pieces of fiber, a couple of pieces of twisted pair, putting them all together, and then pulling that through the house or through the building. That's all part of this ecosystem. Patch cords and pre-mades. Now, this is a really interesting area because people tend to think of a pre-made cable as, these short distance cables that we're going to put in a rack and maybe patch some equipment together with. In the fiber world, that's not necessarily the case. Now, while you can buy patch cords, you can buy short, pre-terminated cables, fiber cables go the distance. They go really long distances. And actually, most companies who are starting out pulling fiber cables, they buy pre-mades. And these pre-mades will be 50 feet, 100 feet, 1,000 feet, 5 miles. You can really build these cables to any length where the connectors come pre-assembled. You have pull mesh, they're really strong. I mean, over 100-pound pull rating. And surprisingly, these pre-terminated cables, because of the way they're manufactured, the connectors that go onto them, they often cost less than buying a bulk cable and connectors and terminating in the field. It's really surprises a lot of people, but this is where we see most folks start their fiber experience. They get pre-terminated cables. Now, accessories. We'll look at these here in a minute. Fiber optic rack trays, fiber optic wall boxes, the electronics, these are different. These are made for fiber. They're made to handle the strands of glass inside the cable. And it's really important that when you're doing an installation, you're using products that are designed for fiber. They'll keep your system running for, literally decades to come. Copper-based equipment, it's built slightly differently. You'll see that. Now, it's the signal electronics, the signal distribution electronics, the network switches, the extenders. This has really been the game changer, okay? When I do these classes live, I'll be standing in a room. You'll have 60, 100 people there. And undoubtedly, you'll have people who raise their hand and they'll say, hey, look, I've worked with fiber. I've done fiber for 10 years, 20 years, never used it, right? I pulled it. I went to these classes where I sit in a room for a week and learn how to polish and, clean my cable and do all of this kind of stuff to it. Never used it. Why is this different? And frankly, the reason we're talking about fiber so much today is, one, we need the bandwidth. Up until recently, we didn't really need more bandwidth than what Twisted Pair gave us, the Cat 5s, 6s, 7s. It covered all the bandwidth we needed. That's not the case anymore, as you'll see here in a minute. But more importantly, there are devices that actually plug into your fiber. It's been a game changer. We can use it for networking. We can use it for AV distribution, control signal distribution. All of this can be actually sent over the optical cable, so people can actually use the cables that have been installed for years and pull cables that we can use today, tomorrow. That's been the game changer in the industry. Why? Why are we talking about this so much? Well, so much of the AV industry is dictated by video resolutions. And anybody who's been doing this for a little while, you've seen this progression, right? Standard definition TVs, remember those Sony Trinitrons that weighed 400 pounds and you'd have to get 5 guys together to move these things, from place to place? Well, that's graduated into 720p. 1080p. And now today, the predominant standard in most installations, it's 4K, okay? And 4K is a very interesting thing, right? Because depending on what we're doing with that 4K signal, it could be 10 gig. Some manufacturers call it 4K 30, 10 gig 4K, right? HDMI 1.4 for 4K. There's a lot of ways to parse it and explain it. But the punchline is, 4K will go up to 10 gig, or if we're enabling HDR, if we're handling a 444 color space, we're going up to 18 gig. And that's really important because when we look at Cat 5, Cat 6, Cat 6A, Cat 7, it all maxes out at 10 gig. But just about every installation we talk about now, we're pushing 4K 60, 444 HDR up to 18 gig. So the signals we're working with today are exceeding the max capacity of our Twisted Pair cable. It's a problem. Now, this is not to say that we can't send 4K HDR over Twisted Pair. We can, but we got to compress it. And HD-based T extenders, really any of these products that leverage a cable that maxes at 10 gig, we're compressing the color space to get those signals from point A to point B. It's not ideal though. Anytime you compress a signal, you're introducing latency, you're introducing, artifacts, you're compromising that signal. And I always tell people, look, if you're installing a $10, $20, $30, $50,000 projector, $50,000, $100,000 theater, why would you compress the signals? Especially when a fiber optic cable, you're going to spend $50 on it. Extenders, they've come down in price. You're in it for, $300, $400, $500. You can stay native. It's very important that we start thinking that way because we need to think about future-proofing our installations. And while it is possible to compress a 4K signal and run it through a 10 gig cable, it is not possible to take a 48 gig signal, essentially an 8K signal, and compress it down below that 10 gig threshold, especially over distance. It's too big of a compression algorithm. It's too much bandwidth. We have an issue. And 8K is a very different standard than what we've seen in the past. So there's a couple of things, a couple of moving parts with the 8K specification. One, we are starting to see 8K displays. We've actually seen these for 2 years, okay? Content. Doesn't matter if you have a display if there's no content. And most people choke up when we start talking about 8K content. And this is where it starts to get interesting because there is actually a lot of 8K content. In fact, there's more 8K content natively than there's 4K content. And that's because we've been filming sports, movies, TV shows. We've been filming things in 8K for years. The problem has been we're not broadcasting it out because there's no 8K displays. And frankly, the networks, our distribution networks, our broadcast industry, there's not a way to get that big signal to the home. And this is where 8K gets very interesting because it's the first broadcast standard that's not designed for traditional broadcast. It's designed for streaming. And this is one of the things that we're seeing affect the AV industry, right? Consumers, we're moving away from that traditional set-top box, especially when we're talking about residential installations. We're moving to streaming. Apple TVs, Roku's, even in the commercial world, more and more audio and video is moving to streaming protocols, streaming distribution. And 8K is the first standard that's designed for this. Now, through a simple checkbox in software, your provider can move you from a 1080p to a 4K to an 8K signal. And this is one of the things we've been seeing the industry gear up to do for quite some time. This is why companies like DirecTV, satellite company, moved into streaming. Charter, Spectrum moved into streaming. AT&T, we can go through the list, right? This is where things are going. And it makes the network as well as the AV completely reliant on bandwidth. And while the AV is very important, right? Video resolutions, 8K, 12K, 16K, whatever comes in the future is very important. We can't lose sight of that network because frankly, the network is one of the most important parts of any installation today. Networks are mission critical. They're mission sensitive, right? Consumers, they care more now about their network performance than they care about any video distribution, audio distribution, because it is all tied to the network. And it's not just video. Look at the average middle class consumer home in the United States. And this is average, okay? Most of us don't sell to average consumers. Most of us are selling to fairly affluent consumers. But that average middle class home in the United States, we've gone from, in 2018, 23 connected devices. And to take a step back, think about that. What's hitting the network? Well, it used to just be our phones, our laptops, maybe a tablet. Today it's everything. Our wearables, like our watches, security systems, TVs, thermostats, appliances. Half of my kids' toys that I buy now have a web-enabled option to them. All of these things hit the network. And this year, 2020, we're expected to see the average middle-class home eclipse 50 connected devices. And now we throw streaming video on top of that, streaming audio on top of that. It's a large ask. And this is where fiber really starts to play a major role. And there's other benefits too. So we talk about immunity. If you go down to Florida, where we have lightning, right? South Africa, where we have lightning. Areas where you have lightning concerns. Fiber is completely immune to that. Areas in the Southwest that are prone to static electricity. Fiber is completely immune to that. Power surges, RF interference, electromagnetic interference. This is why we use fiber in like yacht building. This is why we use fiber in factories and these long distance runs. It's completely immune to all of this interference. We can go long distances, great applications. So casinos, one of the big consumers of TechLogic's electronics, we see them going into casinos. We will have runs in these properties, miles long runs, and we're delivering 4K content with zero latency, literally over, thousands of feet, miles of distribution. Fiber delivers that. They're lasers, they're optical signals going through glass. Not quite at the speed of light, but getting close to the speed of light, you're moving really fast. So you can go long distances. Fiber doesn't corrode like you see in, metallic cables. But again, like I said earlier, none of this really matters if you can't handle the cable easily, if it's not affordable. You need to be able to integrate this in a real world. And that's where a lot of the developments in this technology have come into play. So one of the questions that we often get asked is, how does this compare, right? So we're talking about fiber, but I'm out here, I've got a decade worth of experience pulling Cat 5, Cat 6. Am I limiting myself, for future proofing? Because I thought if I pulled Cat 6, right, I thought that I was going to be future proof. Now I'm telling you that, look, you're not, you're maxing out bandwidth. Is fiber really going to future proof? And how does this compare to some of the new twisted pair standards like Cat 8 that we're starting to see? Well, we can really break these things down. And I mentioned, on the third slide of this presentation, there's a couple of different types of fiber. You can get into a clear line SSF, which is a polymer coated fiber. You can get into Corning standard fibers like the Clear Curve, the SMF28 Ultra. So we can break these things down and actually look side by side, Cat 6, Cat 6A, Cat 7, and Cat 8, okay? Couple of things I want to point out before we start rolling into the design portion of this webinar. Pricing is usually what strikes people right away. You can buy single mode fiber. This is the stuff that you're using in, commercial applications, wiring Demarcs, a lot of residential applications, 20 cents a foot for duplex. That means 2 pieces of fiber. So this is going to really future-proof you, whether you're doing networking, control, video distribution, audio distribution. It's a universal cable, 20 cents a foot. This is less expensive than most Cat 6A, certainly less expensive than Cat 7, Cat 8. Bandwidth, over 100 gigs. In fact, these modern fiber optic cables, 100 petagigs worth of data, 10,000 times more bandwidth than that Cat 7 cable that you're pulling today. You are future-proofing here. Cable diameter. You're dealing with a 4.4 or a 3 millimeter cable. It's tiny. And that little tiny cable has over 100 pounds of pull rating, 4 times stronger than just about any other twisted pair cable that you're going to work with. And the bend radius of 3 millimeters to 7.5 millimeters, meaning you can really fit this into installations pretty easily. It is a superior way to cable installations if you think through the issue of power. You can't run power over fiber. You need to make sure that you're powering the boxes that plug into the fiber optic cable on both ends. Sometimes powering means you plug it into the USB port of the display. Sometimes powering means, look, you got to have an electrician drop power out at the gate or at the security camera or whatever it may be. But beyond the power conversation, fiber outperforms in just about every other way. So let's look at the cable, okay? If we take the cable, there's a couple of different pieces, and this is the part of the training where if I'm, live with folks, I like to walk through the actual cable, walk around the room and take the jacket off and show people the inside and kind of the different pieces and parts of what we're working with. Hard to do that on a webinar, so let's look at the drawing here. So we have the cable jacket, right? Just like any other product in the low voltage industry, these cable jackets can be made with plenum or riser compounds, can get into armoring. You'll see armored fiber optic cables, a lot of different technologies around the jacket and the different pieces and parts that affect the jacket. But it's once we strip that jacket back, that you start to really know you're dealing with a fiber optic cable, because fiber has strengthening fibers. And in most cases, from most manufacturers, those fibers are made with Kevlar. Same thing that you're putting in bulletproof vests, you're putting inside of these cables. Even these tiny little 3mm cables, they have Kevlar yarn inside of them. That's what gives it its strength. And when you're pulling fiber, you want to pull by that Kevlar, because that's what's going to deliver 100 to 220 pounds of pull rating, the Kevlar yarn. Now, once we go beyond the Kevlar yarn, we start to get into the cladding and the core inside that fiber optic cable. And this is where the magic happens, because this is where those optical lasers are going to fire back and forth, delivering our high-speed bandwidth. Whether it's video or audio or network traffic, we're moving those signals through this optical core inside of this fiber optic cable. Okay? Now, depending on the way the cable's constructed, that core could be all glass. It could be polymer-coated glass. You're seeing all polymer optical cables now. There are pros and cons to all of these. It really depends on what we're looking for and how you're using your cable. Now, predominantly worldwide, you're seeing all optic cores. In the AV industry, you're really seeing a mix. Corning type products where there's you're all glass construction, but also SSF, the clear line type cables where you're dealing with polymers that are giving that cable an added amount of strength. Now, these cables, they're going to come in a couple of different formats. Simplex fiber, and by the way, we don't talk about fiber in terms of conductors, 1 conductor, 2 conductor, 12 conductors, or whatever it may be, because we're not conducting anything. We talk about fiber in terms of strand count, and simplex fiber is 1 strand, okay? Now, here's the thing. You may buy electronics that use 1 strand of fiber to transmit from point A to point B. You can do that, okay? My advice to you, and every single time we have a design spec that comes in that somebody's calling for simplex fiber, we contact them and say, look, you really don't want to pull this. You want to pull at a minimum duplex fiber or 2 strands. And the reason is, in the networking world, the standard is 1 strand of fiber sends, 1 strand of fiber receives. Now, you can both send and receive through 1 piece of glass. It's possible. We do it in AV all the time. And as everybody knows, in order to have a bidirectional handshake, you got to have bidirectional communication. So it's possible. Lasers firing at different wavelengths in 2 different directions. But you're not future-proofing. And so much of the fiber optic conversation is, we got to future-proof the installation. And duplex does that for you. Because today you may be using that cable for AV. Tomorrow you may be updating it for networking or some streaming application, 4K, 8K, 12K, 16K, whatever. Odds are, in the future, you're probably going to follow a network standard, which is at a minimum duplex. Now, you also get into multi-strand applications where you may have 4 strands or 6 strands within that fiber optic cable, 12, 24, 48, right? You get into these high strand counts, and the beautiful thing about fiber is these are tiny little pieces of glass, tiny little strands of glass. So you can fit a lot of these strands in a pretty tight jacket. So, let's look at this, a real example. 12 strands of glass, 12 strands of fiber in a 4.4 millimeter jacket. That's tiny, right? That's really easy to pull, really easy to hide in the wall or get through your conduit. You have a lot of bandwidth capabilities and capacities in a very tight space. That's what fiber does. Now, the difference between a multi-strand breakout and a multi-strand micro distribution is how much jacketing we're putting on those inner strands. Breakout cable, these are heavily jacketed, okay? So think of the application where we're running our trunk cable, up maybe a utility pole, we're unzipping it, and we're going out to 2 different security cameras. That's a great application for a breakout fiber. Heavily jacketed, not quite as easy to run because we're dealing with a lot more jacketing compounds and thicker jacketing compounds. Whereas microdistribution, these are the strands, high strand count, small overall jacket, but we really should take these into a breakout box or a breakout rack tray or something where those strands are going to be patched into a pre-made cable or a patch cord or something of the sort. And usually when people have seen this for the first time, they'll look at these tiny little strands inside the fiber and say, man, how am I going to wire that? How are these things not going to break, right? And that's why these rack trays, these panels are so important. Whether you're dealing with a wall box, whether you're dealing with a rack tray, if it's designed for fiber, it's designed to take into account the tiny little strands and manage those, secure them, keep them from, wiggling out of the connectors or keep them from being pinched and breaking, okay? Fiber optic rack trays have coilers built in. They have the strand management. Fiber optic wall boxes, same thing. Coilers, rack trays, breakout pieces. All of these things are used in a fiber optic installation. One of the biggest mistakes that I see is people will take their trunk cable, their long distance fiber optic cable run, and go directly into network switches, or they'll go directly into their extenders. That's not best practice. Best practice is to take that main trunk cable, go into a box, go into a rack tray, patch it from there, because where the wear or the potential damage is usually going to come from is close to that device. Whether it's an articulating mount that's going to, pinch the cable, or a rack door that's going to slam on the fiber, or something of that nature, something like that. The damage is going to occur close to the device, and you don't want to damage your trunk cable. If you're going to damage anything, damage a patch cable that you can just pop out and replace. They're low cost, easy to do. Use the boxes, use the rack trays. Now, there's two different types of fiber that you're going to encounter in the field. You're going to install, you're going to work with single mode and multi-mode. And this is a little counterintuitive, especially if you're used to working with copper-based, twisted pair installations, low voltage, traditional cables, okay? So single mode fiber, the yellow cable here, this is typically used in long distance applications. So, and when I say long distance, I mean more than 1,000 feet. Multi-mode, the aqua, and fiber's color coded. Okay, so if you see a yellow cable, it's single mode. If you see an aqua colored cable, it's multi-mode. And by the way, there's a lot of great cheat sheets online on the TechLogix website where you can type in orange fiber cable. What does that mean? These are standards. This will tell you what these cables are. But the punchline is the single mode, the long distance cable, the 1,000-foot beyond cable, is going to be a smaller optical core. And this is why I say it's a little counterintuitive, because we think in the traditional low voltage world that if I want to take a signal further, I put more copper into it, right? Thicker cable, more bandwidth, more power capacity. That's how we drive long distance. Fiber is the opposite. So that single mode, the yellow cable, that's got a 9-micron core. That's a tiny little core in there. And the reason it goes further is because, think about it, optical waves. What happens is you have waves travel over distance. Well, a tight pipe keeps those waves in phase, whereas a wide pipe, now you may be able to handle more simultaneous waves in that wide, thick pipe, but they start to get sloppy over distance. And that distance tends to be 1,000 to 1,500 feet. That's where multi-mode, the aqua-colored cable, starts to fall apart. Now, does that mean that single mode has to be used only in long distance? No. And frankly, in a lot of commercial applications, you will only see single mode fiber being pulled. Short distances, long distances, Demarc wiring, inside network wiring, video wiring, single mode is the predominant cable. Multi-mode is what we see in a lot of residential applications. You see it in a lot of shorter distance networking applications. There isn't necessarily a right or wrong choice when you're going longer distance or shorter distances, I should say. Single mode's actually a little bit less expensive because of the less glass used, the less amount of glass used in the manufacturing of the cable. But multimode, being a bigger piece of glass, it's a little bit easier to handle in most constructions. And also the electronics that you plug into multimode tend to cost a little bit less because the optical lenses are a little bit bigger and easier to manufacture. Again, not a right or wrong answer. The piece of advice that I give everybody is stick with one or the other. If you're doing a retrofit application and it's got multimode in it, as long as you're underneath that 1,000-foot threshold, stick with multimode, because you cannot natively and passively splice single mode to multimode. It doesn't work. The optical glass sizes are different. They do not splice together. You have to use a media converter or different electronics to splice these different sizes of glass together. Now, there are different grades of glass inside that single mode and that multi-mode family, okay? And single mode is actually pretty easy because single mode, you've got OS1, you've got OS2. It really speaks to the construction, and frankly, most manufacturers are only using OS2 today. So if you buy a cable today, it's OS2, but you're going into an installation that was, installed years ago and it's OS1 cable, these two are both going to be 9 micron. They're compatible. They can be spliced together. They can be coupled together. No problem. It's multi-mode that you have an issue with. So in the multi-mode world, you have OM1 and you have OM2, which are both LED optimized. The issue is OM1 is 62.5 micron. It's a bigger piece of glass. It's frankly a discontinued size of glass. Non-standard is what we call it in the industry today. You cannot take 62.5 micron and splice it into a 50 micron, which is the size that's used for OM2, OM3, OM4, and OM5. Okay? Now, most installations today, they're going to OM3. And as much as I'd love to tell you, future-proof, go all OM5 for everything, that is not what we tell most people. OM3, OS2, OM4, these are going to handle all the bandwidth you really need from just about every installation that, we're going to be working with in a modern installation. That OM3 and that OM4, those multi-mode, they're both laser optimized. Laser is what we use in most electronics today. Move your installations away from OM1 and OM2 and you'll be in good shape. Now, undoubtedly, this raises the question, right? What about future-proofing? Am I truly future-proofing when I pull that OM3 or that OS2 cable? Okay. A lot of guys, again, they thought they were future-proofing when they moved to Cat6. And here we are saying, look, you don't have the bandwidth. You don't have a choice. You got to be in the fiber business today because 8K, 48 gig, 40 gig networks, 100 gig networks. These are the reality now. Am I future-proofing when I put in that OM3 cable? And the answer is yes. Now, the glass cable, this is really important. The optical cables, if you pull in OM3 and OM4 and OS2, you have up to 100 petagigs worth of capacity in those cables. It's the electronics that hold you back. Okay, we just don't have the signaling rates in the electronics to really fully leverage what these optical cables can handle today. It will get better. You will see a progression. You will see costs come down in electronics. There's a lot of moving parts here. But the cable that you are pulling, yes, you are future-proofing by pulling these cables today. Connectors. We spent a lot of time talking about the actual cables themselves. And, I try to keep this session to about 45 to, maybe a little bit longer in terms of minutes, 45 minutes, 60 minutes. So we've got about 10 more minutes worth of content, and then we'll get to some of the questions. I know some folks who are typing in some questions in the line. We'll get to those here in a minute. But before we do that, let's talk about connectors, make sure we're all on the same page. There are several different connectors that affect the installation. LC, SC, ST, which looks very similar to the BNC connectors, if you remember those in the industry, MTR, JFC, and FJ connectors. These all have different applications. They're used differently Again, this is something that I'd point you to the web. You can type in, barrel connector. You can get cheat sheets and articles that'll walk you through how to terminate these connectors and how to work with. For the purpose of the training today, we're going to stick with the two that are common in residential and commercial AV installations. That's the LC and the SC connectors. Now, the good news here is the optical lenses in all these connectors, if they're multi-mode or single mode, they're the same optical lenses, same bandwidth performance. It's just the style of the connector and how they're going to be used. In networking, the LC connector is becoming the predominant connector, and that's because of its size. This is the small one. Some people say LC stands for little connector. It actually stands for a Lucent style connector. That's who holds the patent on this thing. This is the connector you're seeing in those fiber SFP modules that are now in your switches. AV over fiber extenders, high density connections like the patch bays and the bigger network switches that are all fiber enabled. This is the connector that's used for those. And frankly, if you had to pick one connector to put on a cable to future proof it, I tell you to put the LC connector on. It terminates in the same way as its big brother, the SC connector. This is a slightly older style connector. It's a slightly bigger style connector. Some people call it a standard connector or a subscriber connector. This is the one that we're using in a lot of the telecom Demarc wiring. You're seeing this on some of the older multiplexers and media converters and things like that. Again, same optical lenses, so it's not like you're giving up bandwidth going to a bigger connector. We just don't see it on a lot of the networking equipment, or the electronics anymore, because you want to make those things as small as possible, and the LC connector lets you do that. But again, if you can terminate one, you can terminate the other. Same equipment, same tools are used to terminate both styles. It really comes down to, what does your electronics need? What kind of connector are they looking for? Put that on. And if you get into an installation where, maybe you terminated one connector, but it turns out you need the other style, get a crossover cable, get a coupler or an adapter. You can buy these things now that'll flip from one style to the other. Termination. This is the part of the training where I'll walk around and I'll show people how to terminate. The thing that I want to point out here is, if you've got a polymer coated fiber like a Clearline SSF cable, it is a different process than if you're using a traditional Corning style fiber optic cable. The fastest termination time is going to come from like a Clearline cable. These are the most durable. In my opinion, they're one of the best built products in the industry. You can terminate these things pretty quickly. Now, the good news is, if you've got older fiber, if you've got newer Corning, newer Clearline, use the same tools. So a lot of these toolkits, they're universal in design. The connectors are universal in design. It's just a process of termination that becomes a little bit different. If you do go with a Corning style, not a Clearline style cable, plan on an extra 15 to 30 seconds for the termination time. And by the way, you can go on the website, you can watch a video, learn how to terminate in, anywhere from 3 to 5 minutes. It'll walk you through step by step. And the good news is, the tools and the connectors, they really force you to go step by step. So, you're not going to get sloppy. You're not going to miss things, because you can't go from step A to step B to step C without doing the process properly. Let's talk about a couple of applications, and then we're going to end the session with design and troubleshooting, the places where guys get in trouble. Okay. But application, Demarc wiring. I point this out because this is another one of those very common mistakes guys make, okay? They think that the fiber that they're going to wire in the house should be multimode, because that's kind of one of the standard cables. And remember, multimode is the aqua colored cable, one of the standard cables that most people use to pre-wire. They run that out to the Demarc box thinking that AT&T, Comcast, Spectrum, whomever is bringing fiber into the home, they can use it. And the unfortunate answer is they cannot. Service cables, these are single mode. You need to pull single mode to those outdoor Demarc boxes. And by the way, one of the best things you can do when you're pre-wiring a house is put the Demarc box outside yourself. Run the single mode fiber to that box, because then you're in control of where that Demarc's going to be. We see this all the time, right? You know the telecom company's coming in and they're like, okay, where am I going to put the Demarc? Hey, good news, I'm going to put it right next to the doorbell. Or hey, you know what? I think I'm going to put it on this post that's 50 yards away from the house, and good luck trenching. No, you wiring with the fiber, bring it out to the box. You choose the box location. Just make sure you're pulling single mode into the house, wherever that modem's going to be. Beyond the modem, you pull whatever you want. But until you hit that modem, you want to be working with single mode fiber. Media conversion, okay? Another really common application here, using your fiber for RJ45 devices. Because the reality is, most of the electronics out there are still twisted pair, whether they're security cameras or access points. Most of the network switches, they are not fiber enabled. It will be. You're starting to see it in the industry, but the reality is the vast majority of electronics still are copper-based. And a media converter converts the fiber to twisted pair and vice versa. And these things aren't expensive. I mean, we're talking like $50, $60, $70 for a box that will let you take any copper-based product, media or security cameras, relays, gate cams, all that kind of stuff, and run it over fiber optic cable. Very common application. If you've never seen a media converter, these things are going to be your best friend, because now you can leverage all those distance and electrical immunity and RF immunity properties of fiber optic cable to run your twisted pair based products. AV over fiber. One of the things, as I started this session, you now have black boxes that let you use the fiber optic cable to distribute your AV signals. This has been a game changer. That fiber is useful now. And for people who've never seen these boxes, they look a lot like HD-based T extenders. But instead of twisted pair ports, you have fiber ports. But same thing. Here's your HDMI, here's your DVI, here's your control, here's your network interface, where if you do want to run, a traditional 1 gig network or whatever and interlace it with that video and audio and control, you can do that, but you're running it over a fiber optic port. But they're black boxes, just like you've seen in the industry for years. USB over fiber. This is something that's actually really growing in popularity, because you're seeing more and more super speed USB devices in boardrooms, in classrooms, even in the home. These super speed devices like cameras, they're really limited in distance, 5 meters. So 5 meter max distribution distance, but guess what? You have the bandwidth in fiber. Now we can extend those signals hundreds of meters, right? So we can go long distances. Very common application, running USB over fiber. All right. Final area, I promise, then we'll get to a couple of questions. If you have been thinking about questions, this is a webinar, so everybody's muted, but you can type those into the little question area of the GoToMeeting widget that should be on your screen. But before I get to those, let's talk about a couple of areas that are going to sync your installation. Link budgets, areas of loss, very, very, very important. And frankly, a link budget is something that most people who've been working with fiber for years don't really fully comprehend. And the reason is they haven't needed to. And here's the reason why. I'll get to that in a minute. But before we get there, let's understand what that link budget is. It's comprised of the loss budget and the power budget. And the easiest way to think about this is, okay, we have an anticipated amount of loss on any cable run, just like in the twisted pair world, right? We can look at that cable run and say, well, I'm going through a wall plate, a patch panel, I'm going up 200 feet. I can ballpark how much loss I think is going to be in that installation. And then the power budget, put that with the power budget, which is how much loss can my installation tolerate before it doesn't work anymore? What do my devices need? If I'm running an extender, it can only take so much loss before this thing doesn't work. It doesn't have good signal anymore. And the reason I say that most companies who've even been working with fiber don't understand this concept is because they've been working with networking equipment. And frankly, the power budget for network devices is pretty tolerant. I mean, we're talking 11 dB all the way up to around 20 dB. And why is that? Because in the networking world, if you have intermittent signal or, poor signal quality, you're going to have packet loss and just a slowdown of the signal. It'll still work, it'll just be slower. In the AV world, if we're doing like AV over IP or HDMI video distribution, what happens when we have loss? Well, we have intermittent signal. While your customer might not notice a little bit slower streaming speed, they certainly will notice flickering video on their TV. They certainly will notice pixelation of images, okay? That's what we would consider a catastrophic failure. So it's very important that we work within a power budget of 3 to 5 dB for most video installations. You have to be pretty good at what you do if you're working with fiber in the AV world. Where does this loss come from? Well, actually, unlike the copper world, it really doesn't come from cable over distance. Again, we're dealing with glass, we're dealing with lasers. It comes from those splice points, whether it's a mechanical connector, these are the connectors that you snap on in the field, splices, wall plates, patch panels, all of these things are where your loss comes from. So in a real world application, okay, and I know there's commercial guys on here, forgive me, I use a residential application because most people can look at this and you understand this from your home. You have a rack of equipment, you've got an HDMI source, media player, or whatever, a DVD player, Blu-ray player, whatever it may be. You're running that video through an extender over bulk fiber into a wall plate and then a patch cord going to the remote receiver. We can look at this installation and say, okay, I'm doing a tolerably okay job putting my connectors on, running my cable. All of these things put together, I should be operating at about 1.3 dB of loss. My budget is 3 dB, so this should work fine, right? 3 dB of loss, or of power budget, 1.3 dB of expected loss. This should work fine. It's when we get out our meters, our test kits, our little VFL, which is a laser. This comes in every termination kit that you're going to buy, this little laser that checks your connectors. And we find out that, wait a minute, I'm at 5 dB of loss, or I'm at 11 dB of loss. We got a problem. What do we do? So this is where you're going to go back. You're going to use that VFL to check your connectors. You're going to use your meters to identify which run. Remember, duplex fiber, 2 pieces of fiber, 4 connectors. Where is my failure coming in? I will tell you though, if you check your connectors and they're terminated properly, the vast majority of the time, loss comes from dirty installations. And this is where best practice really comes into play. Anything fiber optic is going to come with dust caps. Keep those dust caps in place as long as possible. If you are going into an installation where there's cable that's already been installed, pre-existing connectors, patch cords, network equipment, whatever it may be, it's a good idea to clean those before you use those, because all it takes is a little pollen in the air, some dust, oil from your fingers, leftover, barbecue sauce from lunch, whatever it may be, that can get on those optical lenses and disrupt the performance. And this is why one of the best friends in any fiber optic toolkit is going to be a pen style or click style cleaner. These things are very low cost. I mean, we're talking like $65. You can clean up to 1,000 different ports or connectors. It'll take your loss from, catastrophic not working anymore, 5 dB or whatever it may be, down within the specification. But remember, you're dealing with optical lenses, you're dealing with lasers. You got to make sure that everything stays clean. And if it doesn't stay clean, you got to clean those. Final thing I'll mention here, fiber, especially modern fiber, it has a very tight bend radius. I mean, we're talking 3 millimeters, 7.5 millimeters. But older cable that you might encounter, you got to handle it carefully, because a lot of that older fiber, 1.1 inch bend radius, or even beyond that, even bigger than that. You don't want to break that fiber. In fact, one of the best things that can happen is you handle it rough and you break it and you know you broke it. What tends to happen with older cables is it'll get a crack in it, and then over time it'll slowly degrade. It's a really hard problem to troubleshoot. So you want to make sure you're careful when you're working with a lot of that older fiber optic equipment and cables and things like that. With the modern, if you're going with a modern Corning cable, clear line type cable, these have really high bend or really tight bend radiuses, really high pull ratings. These cables are really easy to operate with. So with that, I know we're coming up. Let's look at a couple of the different questions here. And I see a couple of things. So first question, when are 8K manufacturers going to drop HDMI and go straight to fiber optic inputs? Good question. I get asked this quite a bit, and as much as I'd love to tell you that you're going to see it next year, the reality is I don't think we're going to see it for quite some time. Now, you are seeing SFP ports on a lot more devices. SFP is basically that optical port, small form pluggable port that's on a network switch. Media converters, a lot of the AV extenders have them. But I don't think you're going to be seeing your TVs or your media players, things like that, having optics, certainly within the next 3 to 5 years. What I think you will continue to be seeing is hybrid installations, where you're still pulling that twisted pair cable for a lot of your short distance patching, but certainly your trunk lines, certainly your 8K and ultra high resolution video distribution, that's where you're going to be using fiber optic natively. Don't give up Cat 5s yet. Still pull your Cat 6 cables. What I tell everybody when they're pre-wiring is, instead of pulling 2 or 3, pull 1 twisted pair, 1 fiber. You're really not going to regret that. All right, so next question, ARC and CEC. Can we send those over fiber? And the good news is, yeah, if you're using modern electronics, in fact, most of the fiber optic extenders, the HDMI over fiber extenders, they handle CEC. They even have ARC breakouts. That's one of the things that I'd recommend we take a look at on the TechLogix website. If you go to the extenders, you'll actually see that performance and those breakouts on the actual extenders themselves. Slide deck. So we have a question, can I get the slide deck? And hey, good news is yes, this is the class we teach for CEDIA. Everybody who's on the call today, you'll get a link for the recording of this session. You will also get the slides and a couple of links for, quick reference guides, things like that. All right, a lot of questions this morning, that's good. So media converters for 4K HDR and USB using multi-mode cabling. Again, this is another good question, but you've got a lot of options. It used to be there just wasn't a lot of things for running 4K HDMI over fiber. There are now. You've got several different models for both the video and the USB to choose from. It's all consolidated on the TechLogix website. You should see that www.tlnetworks.com. Go to the fiber infrastructure page. You'll see that information, kind of a quick reference area. All right, power budget. So one of the things, we've got a question about power budget and an ideal termination. So there's a couple of ways to look at this. Why is a power budget? Why is maybe a realistic number different than an ideal number? And the reality is your power and your loss budgets are kind of dictated by the types of connectors that you use and how solidly you put those connectors on the cable. You will always get the absolute best performance from a fusion splice connection. And this is why in a lot of the broadcast and, like government military applications we use fusion splice connectors, or we'll splice different cables together. We'll take the glass and, fuse it together. Now in AV installations, that's not always the case. You use a mechanical connector, you're going to have a little bit more loss. People will ask me, should I always fusion splice everything? No, I don't personally. My house is wired up with fiber. I don't use fusion spliced ends because, frankly, I'm well within the link budget. Now, you will have a little bit of tolerance. This is where getting a test kit, where you can actually meter the amount of loss on your actual runs is useful. But if you're only doing a couple of installations here or there with fiber, until it starts to become that everyday installation, I tell guys, the VFL, it's a laser. It's going to come with your toolkit. It's going to test your connectors. Get the meter and the test kits down the road. All right, let's take a look. Couple more questions. Pinpointing loss. So there's a lot of different things that we can talk about with pinpointing loss. Instead, what I'm going to do, you can type in our web on the website Troubleshooting Fiber, and it'll bring you to an article that actually will walk you through how to pinpoint loss and where those points of loss come in. And anybody who's never been to the website, I certainly recommend you go there, because search bar is not just find me a product. It's really nice because it allows you to search articles and different topics and really zero in on things that you're looking for that may or may not have anything to do with the product. All right. Final thing, detail on terminating fiber. It's really hard to get into terminating fiber in a webinar like this today. What I would recommend, we have a training page online. You can see where live workshops are going to be, and actually CEDIA, so the CEDIA Tech Tours. If there's an event that's by you, it's a great thing to look at, because, literally across the nation, we teach people how to terminate. But also there's a lot of TechLogix distributors out there and TechLogix reps that know how to train on termination. That's a nice hands-on opportunity where it'll get you going with fiber. But the videos online really shouldn't be understated. There's great videos. You can watch step-by-step on how to terminate. You can, see termination guides. In fact, all of the new eco fiber. So this is a new line of fiber, bulk fiber we just launched. When you buy a spool of fiber now, it comes with a how to terminate guide on the side of the box. So it's surprisingly easy. You'll be surprised. Guys think that this is a really difficult topic. It's not. You can terminate fiber, after a couple of tries with reusable connectors. Mechanical connectors are reusable. It's an easy place, an easy direction to move your business into. All right, with that, we are coming up on our time. Again, thank you everyone for attending the session this morning. You will get a link to the recording if you want to share that with other folks on your team. You will also get the slides. You'll have those and some different resources that you can look through and go to online to really kind of keep the knowledge going. I hope everybody has a great rest of their day. Take care and feel free to reach out to us with the contact information on your screen if any questions arise.